Have you ever been trying to configure your SSH for like a server, trying to connect to it, and or like even a computer in your house, and you're just having so many problems? Like, why isn't it connecting? Has this happened to you? Because it's happened to me tons of times. And I've configured servers, I've configured home servers, and very often I get trouble trying to, I mess something up. It's always the case that I mess something up. So with this video, I want to talk to you about the things that I've discovered over the years of configuring SSH, and really breaking down the main things that have caused me trouble. So, okay, I'll get started. The first thing is the SSH daemon. So if you go onto your machine, I'm actually going to go onto my Raspberry Pi for this demonstration because it's using systemd, and your system is most likely going to be systemd based as well. So when you're in systemd, you can check sudo systemctl. That's the command to check systemd stuff. You're going to do status SSH. And you're going to see here that SSH is in fact running. Well, it's active and running, and it's enabled. So this is good. It's actually up on your system. If you get if this is red, this is green right now, but if it's red, then that'll mean you're not running SSH. So you probably want to get that done before you try and connect via SSH to your computer. And yeah, if you don't have SSH on your system, like that's just not a thing, you get an error with this command, then install SSH. That could also be a problem. Now I'm going to show you on OpenRC because this is Artix that I'm running right now. Yeah, I'm on Artix, and what flavor of Artix I'm on is OpenRC based. So on OpenRC, this is also valid for Gen 2 as well. You're going to do rc service, sudo rc service sshd status. You're going to see that the status is started, so we know that it's working. We know that it's on. So with that out of the way, and you know that your SSH is in fact running, we can now go on to the next thing, which is pub key authentication. So there are two main ways of connecting to a server through SSH. The first way is going to be with a password. This isn't as secure, and it might cause you some problems. So the second way, which is more secure, is public key authentication. Now what this is I can show you. So we're going to go into our Raspberry Pi again, and we're going to show you /etc/ssh, and we're going to neovim into sshd_config. This is the important file. You have tons of files in this directory here. I don't think you'll have as many as me. I have some like keys, public keys, that sort of thing. You won't have that. You should have this file, you should have this file, but this is the important one here. So we're going to open that file in a text editor, and you're going to see here a few things. One thing to note is I'm using a non-standard port. I'm actually using port 2222. But you can see here, pub key authentication is enabled, and I have password authentication disabled. If you want, for testing purposes, to enable this, you can. This might help you troubleshoot and figure out if this is the problem with your system, but I keep mine disabled so that I can use a pre-established public-private key pair to log into my system. Yeah, again, it's important to note that I'm not using a standard port. If this was commented out here, if this was like this, if this was like this, it would automatically use port 22. And I'm using 2222 for security reasons. It's good to use a non-standard port for services like this, just in case attackers are scanning IP addresses and happen to find yours and your SSH port is open. That's not good. You don't want them to know that it's SSH. Make it a mystery, you know. It's security by obscurity, as they say. So we have that pub key auth. There are a few things to note with this. The first thing to note is that you actually need to have a public-private key pair. Am I too loud here? I'm a little too loud. You need to have a public-private key pair. So, okay, there's an important file or important directory that you need to know about, and that's going to be in your home directory, and it's going to be called .sh. So we're going to go into this directory, and you're going to see here we have a few files. The ones that are important are this one, and I believe that's it. That's the most important one for our purposes here today. And what this file is going to have is the contents of all of the public keys of all the hosts that have access to the system. I'm not going to show you because it has emails and stuff of people, myself, that I don't want to share, but you can imagine what that'll look like. And for example, I'll actually do a little demonstration here. How would you create a public-private key pair? Well, it's fairly straightforward. I already did it on a previous run of this video, so I'm going to remove all of those, and I'm going to show you. The command is called SSH keygen, and this will be important. So you're going to want to leave this as default. That's usually the best option here, but for this, I'm going to give it the path of this current directory, and I'm also going to call it test key. And for this, I don't want a passphrase. It's more secure to have a passphrase in case anybody gets a hold of your private key. This will just be another layer of security, but I'm not going to do it for this this instance here. And we're going to get our little random art image, and that's not important. But what is important is we actually created the private key and we created the public key. Now with this public key, this is the thing that you're going to put onto that Raspberry Pi or that server. And I'm going to cat testkey.pub, and you're going to see here, this is my, this is the kind of key that it is, the I believe the algorithm that's that created it, and you're going to have the contents of the public key, and then you're going to have the host. My host right now is willc at Zara. My computer is Zara. My username is willc. Okay, we have this. We need to get this onto the Raspberry Pi. Now, where does it go? Well, it goes onto the authorized keys file. So we're going to take this, and we're going to go to our Raspberry Pi. In this case, you probably wouldn't have the ability to connect like this. If you did have the ability to connect like this, and you already had an SSH connection, you just wanted to make another, add another person to the connection, you would use something called SSH copy ID. Read into this command. It would help you a lot here, because then it would save you from manually having to go into here and going into .ssh and going into authorized keys. I'm not going to show you my authorized keys file. If I did want to show you it, I just open it up in NeoVim. I'd copy paste it onto a new line, the contents of this this file, or yeah, this right here. I just open up a text editor and literally copy paste onto a new line. But I'm not going to do that. I'm going to actually echo this, and I'm going to use 2 greater than symbols. If you only have 1, it'll overwrite the entire file. So use 2 to append to a new line on that file, and we're going to go to authorized keys. And what this will do is it'll put the contents of my public key onto a new line of the authorized keys file. And then, if all goes well, you should be able to connect to your SSH, through SSH to your server. So yeah, if you don't have a pre-existing SSH connection like this, you can, if you have access to the computer, just plug in a monitor, plug in a keyboard and stuff, and manually copy paste it. But I don't need to do that. The last and final thing, I believe, is it? Where do I have it? Here it is. Okay. Not the last thing, it's the second last thing. It's your firewall. There's a good chance that you have a firewall on your system, and it's set up to exclude SSH, or it's not set up to include or allow SSH traffic to go through your firewall. Now, in order to check this, there's a command called iptables, I believe. What would this be? List? No. Sudo. Okay, so I think this works, but this is not what I use. I use UFW. If you have a firewall, maybe you're using iptables, but I'm going to assume that you're using UFW. Do whatever commands work for your specific firewall software, but for me, I'm going to do sudo ufw list numbered. And you're going to see here status. It's status numbered. What? What the heck? It should be status numbered. Oh, I'm not even on my Raspberry Pi, that's why. That is why, okay. SSH Pi, sudo ufw status numbered. Okay, so you're gonna see I have all these ports allowed. This is probably not great, but here's the port that I have enabled. It's this one, and it's non-standard. You're gonna look for port 22, and you're gonna see if port 22 is allowed. And if it is allowed, then great. That's what you want. If it's not allowed, you could do sudo ufw allow SSH. This will allow SSH, which by default is port 22. It would be the same thing as doing allow 22. So, now that we have that, we can move on. Yeah, just as a troubleshooting step, if you want, you could just disable your firewall entirely. I wouldn't recommend that, especially if it's like a mission critical system that you're working on. Don't disable your firewall because you're then very susceptible to attacks. So like, be wary. But if it's just on your local network, I'm sure like nobody's really gonna, your brother or sister isn't gonna try and hack you, I don't think. So, the last thing is permissions. This thing is what screwed me up the most when I was setting up a virtual private server. And, you know, in addition to that, you know, any server. I've had so many problems with permissions, and it's usually because I screw up and do something stupid, but, you know, hopefully you're more lucky than me, or smarter than me, I should say. If we're gonna go into .ssh here, I can show you that you have this authorized keys file. If you're going to list this this file and have it shown its access control modifiers, you're going to see here that it's read write, no execute for the user, nothing for the group, and nothing for other. And now, if this is anything different, I'll start with saying this. If this is not what you see here for you, you're going to have a problem. You need to have these permissions, or else there's going to be issues. So, figure out that. Make sure that is what you want it to be by using ls-l. If it's not that, I could show you, it's a command called chown. So we're going to do chown, and I'm actually going to make a new file, test. And this new file, LL is just ls-l. I have set to an alias. It's going to have this. So this is not the same as this. How do we make this the same as this? Well, it's very straightforward. We're going to do chown, chmod, change the modifiers, not change the owner, change the modifiers. And we're going to, well, what are these modifiers? What values do we put here? We're going to look at these values as 3 sets of octets. So we're going to have one binary number, we're going to have the second binary number, and we're going to have the third binary number. This binary number, you know, binary usually goes 1, 2, 4 as the placeholders. So we're going to see here that we have R is in the 4 column, W is in the 2 column, nothing in the 1 column. So 4 plus 2 is 6, plus 0 is 6. And now for the next two, they're both going to be 0, so we're going to do 0, 0. And that's our modifier. That's going to be our access control thing. So now we're going to just specify that we want to change the test, and we're going to LL again. We can see that we have the proper permissions. Now let's say this file is owned by root, because this has happened to me before. Sudo chown root test. We can see here that it's owned by root now. Now, how do we make this not root? So check if this is owned by root. That's not good. If this should be owned by the same user that you're trying to log into, which is Will in this case. It's yeah, what I have an SSH connection to now. And like I just did, we're gonna do sudo. Oh, we're just gonna do sudo chown Yeah, because it'll be owned by root. You need root privileges in order to change the ownership of that file. We're going to do chown, and then we're going to do will, and that's going to change it back to will. Not only is the authorized key file important, but also the whole directory. The whole directory here, we need to list all of the files to get SSH. Yeah, okay, so the whole directory needs to have the proper permissions as well. And also just like check the whole absolute file path. Check all of these as well, make sure that that's working too. And they're what they need to be. So RWX, that's going to look like, for this octet, 4 plus 2 plus 1, 0, 0. So if this is wrong, then you do chown, no, chown 700.ssh, and that should change your permission to what it should be. Now I'll just show you what I have here. So we have RWX RR, and then for home we have these, just so you have a reference if this is messed up. Okay, I think that's all I want to show you, really. That's everything. Yeah, thank you for watching. I hope this lets you get a bit of insight into what you need to do in order to make SSH working again. I know I've had tons of problems with this, so if you're still having problems, I don't know, leave a comment, maybe I can help you figure it out. Yeah, we could see. Alright, thank you for watching.